Hello, in this video we're going to do the Pert practice test and we're going to do questions 15 through 18. Okay, so number 15, these are polynomials and it says to multiply these two binomials. So in order to do this, we are going to distribute. So we have to distribute this 2m to everything in here, and we have to distribute this negative 5n to everything behind it. You probably have seen this method called FOIL, but we're not going to talk really about it if you don't know about it, because it really only works if you're working with two binomials, which later on in this example we are working with more than that. So let's go ahead and multiply. So this is really testing your skills of your exponent rules. So in the beginning we need to have our exponent rules for multiplication on, and then later we're going to switch to addition. So let's just think multiplication at the moment. So 2m times 4m. Well, 2 times 4 is 8, and then m times m is m squared, because when we multiply bases, we add cute little exponents, right? So let's do 2m times n. Okay, so in this instance, they don't look like terms, but we can multiply them. So that doesn't apply here. So we have 2 and then mn, 2m times n. Can't really get any more simple than that. So let's do negative 5 times 4, which is negative 20. N times m. Now I know that you could write it as nm, but we, even though we do use letters, we are going to put them alphabetically. So we're going to leave that as mn as well. Really doesn't matter, you can switch those. That's like saying 2 times 3 and then switching 3 times 2. They're going to end up the same thing. So we have negative 20 mn, and then negative 5n times n. So we have negative 5n squared. So now that we just did all those rules for multiplying, then we're going to kind of switch gears. And now I want you to think about adding polynomials. So we need to think about like terms. We need to think about the exponent. The exponent and the variables are no longer changing at this point. So your two like terms when you're multiplying two binomials should be the two middle ones. They should go ahead and combine for you, and nothing else should be like terms. If they're not, and you're just doing two binomials, something might have gone wrong. So we have 8m squared. That's going to stay. 2 plus negative 20, because our variable doesn't change, is negative 18mn, and then negative 5n squared. So that would be B. All right, so let's do number 16. So this is to multiply, and same steps except for it's missing something. It only has this little squared. Well, if you think about it, 6 squared is just 6 times 6. Or 8 squared is just 8 times 8. Oops, sorry. 8 times 8. My 8s, man. So if I did a binomial or polynomial, which is 4n minus 3, a binomial, and I square it, I'm really just doing it times itself. 4n minus 3. So now we get rid of that squared, and now this starts looking familiar. So now we can go ahead and distribute everything to everything. Okay? So 4n times 4n is 16n squared. 4n times negative 3 is negative 12n. Negative 3 times 4n is negative 12n. And negative 3 times negative 3 is positive 9. Again, when you're multiplying two binomials, these two middle ones should be like terms. So we have 16n squared, and then now we're going to switch these. We're just like terms, so a variable is not going to change. Negative 12 minus 12 more is negative 24, and then we have that plus 9. So your answer for number 16 should also be B. All right, number 17. So earlier in the video, I talked about why FOIL doesn't work, and this is an example of it. Because we don't have first, outer, inner, last, but the rules, if you do the distribution method, they work for this as well. So we are going to distribute that 2k squared to everything in here first. Let's go ahead and do that. 2k squared times k is 2k to the third, because remember this one is a little exponent. 2k squared times 3 is 6k squared. Now let's do negative 6 times k. Negative 6k times k, I'm so sorry, is negative 6k squared. Negative 6k times 3 is negative 18k. And now we're going to do this last one. So now we have 9 times k, which is 9k, and 9 times 3, which is 27, a positive 27. All right, so now let's switch gears again. We're going to go back into thinking about adding polynomials. So 2k cubed, I go down the line and there's just not another cubed for him to combine with. So it is going to be 2k cubed, 3. So now let's have 6k to the second. And so I'm going to go down and see if there's any other like terms. Negative 6k to the second, and then there's just no other k to the second. So what if I combine them? Well, 6 minus 6 is 0. So these are actually going to cancel each other out, and we're no longer going to have any k squareds. So we're going to continue this equation. However, just a test-taking strategy, if you are pretty confident that these two are going to cancel each other out, and you notice that A, C, and D all have this k squared going on in here, we could have already had the answer without even going further. But let's just make sure, we'll triple check. So those cancel each other out. So let's get another color. So we have this 18k and 9k, they are like terms. So negative 18 plus 9 is negative 9k, and then this plus 27. Another test-taking strategy, when things that you have like this that you can use, if you're pretty confident that 9 times 3 was positive 27, then you could have eliminated C and D as well. So just kind of having an idea, but the final answer here is B. All right, last one on this video. So this one asks you to factor completely. So what we've been doing the past couple of polynomials is multiplying them. So now we're going to go backwards, and now we're going to factor them. So factors are here. They want two parentheses, and you can tell by this that it wants the same thing. So when you are factoring, the first thing you want to do is take out a GCF, or a greatest common factor, if you can. So if there is a number that can equally go into 4 and into negative 16, you want to go ahead and take that out or divide everything by it. And there is the number 4. That can totally come out. This would change this. 4 divided by 4 would just be 1, and then 16 divided by 4 would be 4. So this changes it to x squared minus 4, because what we did is we took the GCF out. So another test-taking strategy that you could go with from here is if you, before we even factored and we took out the GCF of here, we already could have eliminated all but one answer, because the answer here is going to be C. But I'm going to show you how to do it even further. Just a test-taking strategy. If you're pretty confident that you took out your GCF, then we already found the answer before we kept going forward. But let's go ahead and keep going. So now we have x squared minus 4. Now, the cool thing about x squared and the number 4 that kind of pops in my mind is they are both perfect squares, right? So I can break x squared into x times x. And if you're factoring quadratics, you can always do that. And then 4, I can break down into 2 and 2, because that's the square root of 4. Now, the thing that you have to kind of pay attention to at the very last is that this is a negative 4. So in order to get a negative, 1 must be positive and 1 must be negative. So if you ever get stuck for any reason that this is just, you're not sure if you did this right, you can go ahead and multiply these two binomials and then multiply the whole thing by 4. And I guarantee you'll get this original answer again. So you can always just trust your work, but this answer is going to be C.